So we're in London today, where we'll be taking the course of Structure and Architecture outside of the classroom and into the office of Waugh and Thistleton architects. Andrew Waugh will be talking to us about engineered timber and also specifically about the building behind me, the Black&White building. So let's head down to their office.
My name is Andrew Waugh, and this is Waugh Thistleton Architects. So welcome to our practice, to our office in London, in central London. We've been going for a little over 25 years, and my business partner, Anthony Thistleton, and myself started the practice pretty much straight after college, which, you know, I'm sure sounded to me for many years like a really exciting way of doing it, but actually I think it's kind of been quite problematic in many ways because we didn't know what we were doing. I mean, I think that, you know, architecture is something that you definitely learn by doing, but we hadn't done anything, you know? So we started by doing house extensions and bars and restaurants and cafes and shops, and then, you know, little roof extensions and then little buildings, and then it's just kind of grown over the years. As we've become more experienced, the projects have generally become, you know, larger. And then we built our first mass timber building, our first CLT building in 2003. And we built that building primarily because of prefabrication, because we were very interested. I was really interested at college about prefabrication when I was at university, and the idea that, you know, we could take things from off a construction site, that we could build them, make them in a factory, that they could be better working conditions. I worked on a building site when I was at school, you know, in the summer holidays, and it was horrible. You know, it's cold and wet and, you know, or hot. And I just, like, the whole time I was there thinking, there's got to be a better way of doing this. You know, looking at every other industry, looking at every other way that everything's done, you just think, there's got to be a better way of doing this. You know, and I didn't want to be one of those kind of rarefied architects that talks about kind of like, you know, the beauty of craft and kind of draws things and then sends somebody else off to do it. You know, I wanted to be far more involved in the making of things. And actually, I felt like prefabrication gives us that direct connection, because what we're drawing is exactly what's made, you know, and then the site becomes a place of assembly. And so our interest and fascination in prefabrication was what really spurred our interest at first in cross-laminated timber. And then as we began working in the material, the conversation around the carbon impact of construction became something that was being talked about. You know, and there were new building codes in the UK around having to, you know, have some solar panels on the roof to generate a bit of your own energy, to put some insulation in the walls, to have some double glazing in the windows, you know, because of climate change, because there was this massive, terrible thing hurtling towards us like a train. And so construction, one of the major kind of like, you know, one of the things majorly affecting climate, the response was put a solar panel on the roof, you know, unless you're near a bus stop. And if you're near a bus stop, you don't have to do it, you're okay. And so this is, you know, this is quite apparently insane, and that, you know, it can't, if something this major is facing us, then the notion that we, you know, that we stay on the same route and just add stuff on seemed to me slightly insane. You know, that we needed to actually pause, reappraise our route, our values, our success, you know, and to think about it in terms of, you know, an impending kind of catastrophe. And so, you know, the sense of optimism with which I left college turned into a sense of activism. So I went from an optimist to an activist. And that's why we talk, you know, we talk about what we do, we write about what we do, we put all our drawings on our website of our buildings, we talk about the challenges, we talk about successes too, but we, you know, we're very kind of much a purpose-driven practice.
How do you make sure that people here and you yourself keep connected to the making of whatever you're designing?
Yeah. That's a great question. I mean, I think in a few ways, I feel confident that we do retain that connection, and we do it in a few ways. I mean, for one thing, a really obvious way, and you can see behind me, we just have a whole stacks of materials everywhere, and material libraries everywhere. The other thing is that it's very much part of who we are, of our culture, that we've always been about building things. We've always been about kind of putting things together, understanding materials. You know, funny enough, I was talking to a friend of mine who's a chef the other day about this, and because a lot of our work, early work, was restaurants, and so we're working with chefs all the time, you know, and the chef is always talking about where their food is coming from, you know, where the potatoes come from, whether, you know, having met a farmer or been out to a vineyard, or, you know, and that definitely kind of made me think, nobody's ever said to me, where does that brick come from, you know, or where does that piece of steel come from, or, you know, and so, you know, as a practice, all of us have been out to Austria and to Germany. We've looked at, we've been to the forests, we've been to sawmills, we know the producers, they come in here regularly to meet with us. If people invent new types or innovate new types of engineered timber, they quite often come here and talk through their products, you know, what they can do, how we might use them, that kind of thing. So I think that because we're really involved in that level of innovation and research in the practice, then there isn't a disconnect, because everything that we do is about building. You know, everything that we do is about putting buildings together. And so actually I think that, you know, in many ways we're much more craft-based, you know, than a lot of practices probably.
And how does then the technology help you, like a BIM modeling and things like that?
Technology is absolutely essential. Absolutely essential, and you know, I love it. I love it. So when you think about high-tech architecture, you think about, so for me, if you think about the path of modernism and the history of architecture, for me, the last time that there was any sense of ethos or purpose in architecture was the high-tech movement. Richard Rogers, Foster, Grimshaw. I'm sure there were some great Dutch ones as well. But you know, that kind of seemed to me, and that was already kind of, you know, disappearing when I was at college. But I have always had a fascination for that. And yet, you look at that architecture now, I understand that architecture now, and you see that what it was an impression of sophistication. It was like a handcrafted prototype of what would be one day made by a machine, you know? But it was all, you know, and it was drawn by hand and worked out with a calculator or a slide ruler. So what we're doing is we're using a natural material, you know, taken from the forest, sawn, taken from the forest, processed, manufactured. But the way in which we're designing that material, the way in which we are procuring it, constructing with it, you know, all relies on really precise digital softwares. You know, so we use Revit from the get-go. So we're designing by component, designing through engineering. So our files, our drawing files, they migrate straight to the engineer. You know, all the modeling, all the element modeling is done by the engineer. That file migrates to the factory. So and that's how the cutting out of the panels happens. So what we're doing, what we're drawing here, It's exactly what's going through to the factory and exactly what arrives here. It's fantastic. And that allows us to use as little timber as possible. Right? So every project we do, we use as little of every material as we possibly can. You know, so it's like, let's that kind of touch the ground lightly, right? Just, you know, what is sufficient for its purpose? What is necessary for its purpose?
And you leave no waste on the construction site that way either.
No waste. No waste. No waste, less plastic, you know, shorter time, much quieter, fewer foundations because they're so much lighter. The building's 20% of a concrete building, you know. So all of those different different angles, you know, help to reduce the carbon on the site and through the process. You know, just going back quickly to your other question, I remember, you know, when we were first building stuff, going onto a construction site and seeing one of my drawings in the mud, you know, and looking at it, you know, thinking, you know, and the builder had looked at it, memorized it, and thrown it away, you know, and what was built was always, and is still, an approximation of what was intended. You know, no other industry works like that. Can you imagine a car designer? I mean, it's just like, you know, so I think that we need to drag ourselves as an industry out of a kind of Ruskin romanticism, you know, drag ourselves kicking and screaming into the 21st century, face up to the problems that are facing our planet, you know, and embrace our industry. Sometimes a model is the only way to really investigate things, and certainly with clients, you know, there's a full-scale model, you know, of a piece of wall with a floor slab going into it. You know, we do that for clients, for building code officials, so they can actually see the weight of it, you know, the heft of what we're doing. So we use models, we sketch, but those all go in to this kind of, to an information model. You know, the idea that actually, I love the idea that also that what we're producing in our office as kind of a drawn information, is a set of instructions, a set of intent. And so you move from design to intention, you know, and that transformation from design through to intention is the art of the kind of, you know, is the art of kind of architecture in a way. And I think that when you have these kind of, when you have this information about how to build something, then that should always be there. You know, when the building's finished, you don't throw away the drawings. The drawings go with the building, so that when you need to adapt the building, you have the drawings. When you need to take the building to pieces, you have the drawings. You know, when you need to, you know, we talk about urban harvesting. You know, if you're kind of going and you know, that you actually have that kind of passported information within a file. I love that as well. I think that's really exciting. And
is that then also how you think about the detailing, also in ways of taking things apart again?
Yeah, absolutely. Yeah, so a really big focus of ours as a practice, especially I think in the last couple of years, 3 or 4 years, has been about thinking about details in order that they can be taken apart as well as put together.
You also start thinking in models, or that you also give these models to the world, basically.
Yeah.
Can you tell us a bit more about how that works and why you do that?
What? Why we give it out?
Well, there are not that many architects that that are as open to saying like.
It's quite
hey, we figured all of this out
for sure, and this is what we think.
To you. And
it was a very conscious decision to do that. When we finished, so in 2008, we built a 9-story building out of timber, and that hadn't been done before. And we had a lot of interest in the building from engineers, even some architects, you know, contractors. Lots of interest asking us, you know, very specific questions about fire or moisture or engineering or, you know, acoustics, all these kinds of things. And so Anthony and I sat down and talked about it. You know, we talked about what we thought about this kind of culture in architecture of keeping everything close. you know, and treating everything as though it was a kind of, you know, somehow it was kind of, that it belonged to us. But the truth is that the reason why we are involved in timber is because of low carbon. The reason why we're doing low carbon is because of the climate emergency. And, you know, I don't think that then that is a reasonable reaction to say, well, I'm doing what I can, but I'm not telling you what it is. You have to find your own way of dealing with the climate emergency. That's, you know, it's a global event, right, that affects all of us. So we have to share. We have to talk about what we're doing because we want, you know, because we're evangelical about it, you know, so we want everybody else to be doing this. It's not something that we want to keep to ourselves. You know, everybody should be doing this, and the more that we talk to other people about it, then more they talk to us about what they're doing, and the more we learn. So that's been really a core part of our practice, has been that kind of communication about talking about our work, why we do it, and, you know, and also it drives us as well because we're giving everything out, we have to keep discovering new things, you know, so it's really, it kind of really encourages us to keep moving, to keep innovating. So it's a great driver.
Yeah. Can you explain to us how engineered timber is different from traditional timber frame construction?
Sure. So when we talk about engineered timber, we're talking about a whole family of different products. And that's where you take a standard piece of timber, whether that's a veneer or wood chips or planks of timber, and you put them together, you put multiple number of those individual items together, and you put them together in such a way that you enhance their strength, right? So with glulam, you have planks that are laid out, you know, on top of each other, parallel to the one below, and then you put them in, you glue them and you put them in a press. In CLT, you lay the planks out, you spray them with an adhesive, you lay the next layer of planks on perpendicular to the ones below. And that cross layers of timber makes CLT. And then you have strand board, you have plywood, you have, you know, whole families of different types of engineered timber. And they're all, you know, they're all slightly better at one job, slightly worse at the other, you know, so they all have their own particular kind of place in construction.
And how would you say that then compares to the more traditional kind of way of building with concrete or with steel?
All of the buildings that we know, all of our visual references for architecture, all of the buildings that we love are concrete buildings. You know, so when we're thinking about architecture, when we're thinking about a new design, we're drawing on references that are from another material. And that's really difficult because if you're not careful, then what you end up doing is making a concrete building out of timber, you know? And so actually the way in which timber works is completely different from the way that concrete works. You know, like I was saying before, it's much lighter. So you're not worried about holding it up like you are with a concrete building. It's all about holding it up. With a timber building, it's all about stopping it from blowing over. So that changes the whole nature of the engineering of that building immediately. And then, like I was saying before, because the resource is so precious, you need to think about how little timber can I use? You know, how can I design the building to the engineering capacity of the material? Right? And so that's a whole new way of thinking about buildings. And this is a journey that we're on. We're not, you know, this is not something that we anticipated, you know, so, but it's incredibly exciting because I think that there needs to be a complete transformation, a revolution in the way in which we build.
I'd like to get to the black and white building. Could you maybe tell us a little bit about how the commission started? And also whether, you know, thinking about building a timber building was already from the start of the project an issue, whether the client came in with that?
So the client, yeah, I mean, I met the client, I don't know, 5, 6, 7 years ago at a conference on sustainability, and the client was talking about how they employ sustainable practices within the work that they do. So they're a big commercial developer, and they have lots of co-working space. Where you kind of small offices like WeWork, right? And he was talking about how they put solar panels on the roof and they have green roofs and I was like, a bit more kind of like, and it's like at the end I was just like, oh come on, actually you're a really sustainable developer because you don't build anything, because you take old, tired, empty office buildings and you fill them full of gorgeous furniture and and bean bags and coffee machines, and you revitalize whole buildings, whole areas, whole neighborhoods. And I think it's just, so you have an incredibly sustainable practice. But if you ever do build a new building, it has to be in timber, because you need to keep that culture. This is really important. And so then, a couple of years later, I got a phone call saying we bought a site, want a building. Do you think you could do it in timber? Architecture is, it's always about context, right? It's always about the cities and the towns, the villages that we're building in. It's always about context. If you design a building devoid of any understanding of its context, then that's not architecture, that's product design, and you're designing an object, and objects are not architecture. So we needed to demonstrate first what the kind of volume was on the site that they could anticipate getting. How big a building could we get in terms of the site size, in terms of the context, in terms of the local planning office. So those are the sort of first exercises that you go through. And then from that, you begin to establish a massing, like where the daylight's coming from, because it's a really tight urban site. We've got a railway on one side, we've got historic buildings along the streetscape from the 19th century, then we've got new developments on the south facade of the building. So it's really closed in site. Lots of, rights to light, lots of legal party wall issues. So actually just scoping out the parameters of the site was the first exercise. Then understanding what kind of massing we could get on the site approximately. And then applying a grid to that massing. A grid that works for timber, right? So,
and what does that mean?
About
in terms of size?
In terms of span. Yeah. So it means that 6.5 meters, 6 meters, 7.5 meters are ideal kind of span sizes for timber. If you go above 7.5 meters, actually, if you go from 7.5 meters. So generally, in the UK, the buildings are based on a 1.5 meter grid, commercial buildings, because that's the size that windows come in, right? So you base the whole thing on a 1.5 meter grid. In a timber building, if you do 9 meters, you use more timber than you do if you use 7.5 meters. If you use 7.5 meters, you use more timber than you do if you use 6 meters. So 6 meters is the perfect kind of spot for, at the moment, with the timber that we have, for kind of resource use, for efficiency and that kind of thing. So we plan it out. 6 meter grid though can be quite tight, because especially when you're talking to a client who's used to a 9, 10.5, 12 meter grid from steel or concrete, and then you say to them, we're going to do a 6 meter grid, they're going, oh my God, it's going to be full of columns, it's going to be a nightmare. So we're looking, so on Black&White we have spans of between 6 meters and 9 meters. And what we do is we lay those kind of grids over the site to look for the most structurally efficient solution. Now in this situation, it's sort of basically an L shape, right? And the front of the building to the middle of the building runs front to back. And then at the back half of the building, the south end of the building, it runs from side to side. And at the apex, you have the core. So the structures run into the core, and the core then provides the shear capacity up the building, the vertical kind of strength to the building. And so an understanding of the engineering and working hand in hand with the engineer, not only the timber engineer in the office, but also specifically the structural engineer for the project. And that's not always easy, because I think that over the last decades, there's been this separation between engineering and architecture, and where engineers have become kind of problem solvers, you know, where the architect, you know, would draw something whimsical on a napkin at lunch, then give it to the engineer, you know, scuttle off and make that work for me. You know, and the engineer's like, oh, fantastic, you know, it's like sort of three-dimensional Sudoku or something. You know, and without any sense of, you know, of ethic or of kind of responsibility or of kind of, you know, or even of design, really. The engineer will go off and solve that problem, you know, and come back and say, we can do it in concrete, we can do it in steel, we can do it in timber. And it's like, so we don't let them out the door. You know, come back here, sit down with us, and let's draw it together. So we work really closely with the engineer, especially at the beginning of the project, to ensure that we're designing something of the optimum efficiency. You know, because we don't need an ostentatious shape, right? We don't need massive cantilevers. We don't need to be super tall, you know, because these buildings, the beauty of these buildings is their efficiency, the materiality, you know, we kind of like, we think a lot about the daylight and how you move through those spaces. So these buildings are not about individual moments of grandeur. They're about wanting people to be happy in them, you know, wanting to help people kind of like have a nice place to work and a nice place to be, you know, wanting people in the street to walk past and say, oh, that looks pretty, you know. And so that kind of engineering-led architecture is, you know, very much part of our process. Now, in the Black and White building, we've done something quite distinct, which is that the material innovation that we've been involved in, looking for different types of engineered timber, the relationships with engineers that we have, and that desire to use as little timber as possible has driven us, and also thinking about how the material can be reused in the future, has driven us to look at the connections between the beams and the floor slabs and that kind of thing. So in the Black and White building, we have this super light LVL frame, the beams and the columns, all made from beech LVL, and which is, you know, 3 times stronger than concrete in compression. Really, really strong material. And so your gravitational load is all taken by that super strong LVL, firmly planted. So in order to look at the shear forces in the building, what we've done, what you frequently do is you put the CLT down on top of the beams, you stagger the CLT across the beams as much as you can, and then you screw in along the beam at sort of 45 degrees with these massive kind of 200-300 mil screws into the beam, you know, really chunky, kind of like. It's very difficult to reuse that material. You can saw it out, or you can saw off the beam. It's quite a process, you know. So what we've done on Black and White is, rather than sit the floor slabs on top of the beam, is we sit the floor slabs within the beam. So the beams are all like a T-section, and the floor slabs sit then within the beam. And by doing that, the floor slabs are bracing that structure. They're giving that structure a diaphragm action. And then those floor slabs track back to the core, which then rises through the building, giving the capacity for the structure. So that also means that we've got really generous floor to ceilings because we're able to compact the structure. So we've got lots, you know, we've got another couple of 100 millimeters of daylight coming in. So that efficiency of material, that kind of engineering-led approach, has also allowed us to reduce the amount of timber from our first drawing to what's on site. We've reduced the amount of timber in construction by about 20%. So really driving down the amount of timber that we use. And I think that it gives the building quite a precise feel to it. You know, it doesn't feel chunky. It feels quite, you know.
Yeah, that's also what I noticed while seeing the construction site in real life. It was almost like a piece of furniture being put
Absolutely
together.
right. Absolutely. Yeah. Absolutely. We designed the chair you're sitting on, actually.
Really?
Yeah.
Oh.
And learn a lot from that, because actually, you know, when you move in a chair, the stability of the structure of a chair is really, you know, really quite similar in a way if you think about it.
As a sort of final send-off, is there anything that you would want to say to the students?
Yeah, it's a, you know, lucky you. What a fabulous job. I love my job. I have a great time. I really enjoy it. I think that it's such an important generation of architects. You know, arguably the most important generation of architects that have ever lived. So be an activist, you know, and enjoy it.